what type of a triangle you have given specific side lengths. Before, when we talked about when you had the side lengths within a triangle, we were able to tell if it's acute, or not, sorry, we were able to tell if it was isosceles, equilateral, or scalene, if the three of those held true. But also what you can do with the side lengths of a triangle is that you can determine whether or not it is an acute angle, I'm sorry, an acute triangle, obtuse triangle, or a right triangle, just by knowing side lengths. Normally we used to do that with angles, but you can actually do it with sides as well. And what we do is we use Pythagorean theorem to see whether or not it is equal, greater than, or less than. It is really, really quick and painless to work with. So, here's what you have. We all know that if a squared plus b squared equals c squared, you get a right triangle. Okay? You know that. That's kind of the whole basis of Pythagorean theorem. Which one is better to do? This one, right?
That one.
Yeah. That one.
Yes.
So we all know that if a squared plus b squared equals c squared, it's going to be a right triangle. Now, is it okay if I rewrite it as c squared is a squared plus b squared? Does it matter what side it's on?
No.
The reason why I'm going to talk about it is that if c squared equals a squared b squared, Whiskey, put it away. Thanks. Is because the other two are always written with the c squared first. Okay? So if I look at it, what we have is the two other possibilities. If your c squared side is smaller than the a squared plus b squared, it is acute. If it is bigger, it is obtuse. Okay? So what happens then is that if you know your side lengths, you can check this really quickly. Sorry. Plus, by putting that c squared first, if it's smaller, when things are smaller, we think of them as cute because they're little. They're not really little. For the past 4 generations, every Murphy's son has been bigger than the father.
How tall are you?
6'3". Yeah.
It's 6'5".
I wouldn't be surprised with that at all. The doctor would already say, yeah. You okay with this?
No.
Let me show you some examples. Let me know when you're ready, Whiskey. I'm going to do an example then.
All right.
That sounds good. Barbecue chicken. Grilled barbecue chicken. That fried barbecue chicken. They don't have fried. Grilled is better. Grilled is better than meat too. But it depends if it's Popeye's fried chicken or Popeye's fried chicken.
Let me show you an example. Let's check to see what type of triangle this is going to create. Okay? You need a calculator out because you're going to use it. So what we need to do first of all is decide which of those 3 numbers is the largest. It's 22. 28. So we check it. Is 28 squared? Then we're going to check. Remember when you did this before in like elementary school? You're trying to see is it greater than, less than, or equal to?
No.
The little crocodile thing?
I
Yeah.
was never here for elementary school.
Well, this is what we did, just so you know. So you check it.
I wasn't here. I know.
Well, yeah.
Closer.
That's so stupid.
So 28 squared.
This man.
784.
You were Montana.
20 squared is 400. 22 squared is 484. So 784 is smaller than 884.
Oh, I see.
So is it acute, obtuse, or right? It's acute. That's what we do.
So you just add to them.
And that's how you can do this, checking, without knowing what your angle vectors are, you can still tell whether or not it's an acute triangle or an obtuse triangle by using Pythagorean theorem. Does that make sense? It's not too terrible. Now, what happens if your side lengths have, can I go to another one?
No.
I'm going to.
So will they ever be
What's that? If they're equal, then it's a right triangle. If they're equal, then it'll be a right triangle. All right. So let's say you have this. Let's say you have 10, 12, and the square root of 13. Again, what we have to be able to determine is whether or not, or which one of those is the largest. So which of those three numbers would have to be playing the role of the hypotenuse? 12, good. I'm glad you didn't say the square root of 13. Now, what'll happen a lot of times is if you're unsure, your calculator has a button on it called the square root button. Now, if you type in the square root of 13 on your calculator, it's the multi-view, it's going to spit out the square root of 13. If you need to check your decimal equivalency of that then, what button do you press? The double arrows, very good. So you hit that double arrow button to see a decimal idea of what does that equal. The square root of 13 is going to be more than 3 but less than 4. It's like 3/6. Yeah. Okay? And what I'm doing there is I'm approximating. I know that the square root of 13 falls between the square root of 9 and the square root of 16, but it's closer to 16 than it is 9, so it means it's more than halfway there. That's why I said 3/6. It's a guess. It's ish. Okay? So now that means that the 12 has to be the largest. So we check it then. So 10 squared, oops, sorry, we put 12 over here. 12 squared relationship to 10 squared plus the square root of 13 squared. Now, here's a little trick. When you have the square root of junk squared, it's always junk. Okay?
Doesn't matter what the jump is.
Correct.
There's junk in that.
So now you're going to get 144, 100 plus 13. So 144 is greater than 113. Therefore, what kind of a triangle is it? Obtuse. Now, in the calculator, one of the other things you can do as far as the square root stuff is concerned, if you need to verify a square root or if you're not quite sure about how that works, my suggestion, always put in parentheses what you are about to square, if it's a square root, in the calculator. That way it groups it all together. Okay? The reason that I'm saying that is because sometimes you might have to take, and you'll have a number of 2 root 13 that you have to square. If you have that and you have to square it, you need to make sure you put it in parentheses. 2 root 13 and then square it. You have to group that whole entire number, otherwise it won't work correctly. What the calculator will do is that it will just square the 13 and it will not square the 2. It won't distribute that function to it. Okay? So make sure anytime you've got a number in front of the radical, make sure you throw that in parentheses. Okay? Or better yet, anytime you square something that has a root in it, please make sure you always throw it in parentheses. You'll just be so much less likely to screw up. Okay? Just a little tip. Get a different number. Oops. One button. One more, and then I'm going to show you one other trick. Yeah, yeah. It's the easiest way to do it because then that way you're always remembering if it's smaller or bigger. It's just one of those little tricks. Usually the book puts it last because you're always used to saying a squared plus b squared. So, but if you look at it that way, if a squared plus b squared is bigger than c squared, you might think that's obtuse. But by saying it first, it's smaller. So you might say, oh, it's little. It's just the way, that's just, it's different than how other things are written. So you do your 12 squared,
65.
7 squared, and a 4 squared.
Obtuse triangle.
144, 49, and 16. Last time I checked, I would rather have 144 Oreos than 65 of them.
I hate Oreos.
You know what? Yeah, that's too many Oreos.
Money. You talking
How
about
about
money?
Have you guys had the white chocolate dipped Oreos? Yes, sir.
Are you talking about those Oreo balls?
No, but I've heard they're quite delicious.
Mr. Are you talking about those Oreo balls?
What's that?
Those Oreo balls with the white chocolate cover?
Yeah.
Those are good. Mom made those this Christmas.
Yeah,
I told them.
It's like diabetes in a box.
Yes.
So,
When you're happy.
so
I tried to land it on there. Mine.
he's suffering. Let's throw some algebra to it. I want to find a value of x that will create a right triangle. I want to find a value of x that's going to create a right triangle.
That's my pencil.
What's that? No. Well, yes, I'm sorry. They would have to be the same here because the value of x is the same for both sides. Now, will those two values of x be legs, or will one of them be a hypotenuse? They have to be legs. And it goes back to what you were just saying. These both have to be legs because that is the other side length. If these two side lengths were bigger than that, we wouldn't have a right triangle. You could think of it that way right away. If those both sides were 10, if you had a right triangle, it would have to be 10 squared plus 8 squared equals 10 squared. Well, we know that doesn't happen. So these two will be smaller than the 8. Okay? So in order for this to work, what theorem has to hold true? Okay. So we have to have a squared plus b squared has to equal c squared. So here I have my a and b values are both x. Are we okay with that? Now, algebraically, how do you combine like terms here? Am I multiplying these two together? No, I'm just adding them together. So
2x squared?
2x squared, very good. I get 2x squared is equals 64. Are we okay with that?
Yeah.
Okay. Now, I have, again, another two-step equation. I need to get x by itself, so what do I move first? The 2. I have to divide by 2. Very good. So in dividing by 2, I'm going to get x squared is equal to 32. Now, what do I do to get x by itself? Square root. When I square root that, what do you guys get? You have 4 root 2, correct? So that means then the two other side lengths are 4 root 2, 4 root 2, and 8. More specifically now, what kind of a right triangle is that? It's isosceles. It's an isosceles right triangle. If it's an isosceles right triangle, what are your two base angles? If they're the same, they're going to be 45s. These will both be 45 degrees. I don't know if we'll get to it tomorrow. We might wait till Monday to start the whole 45, 45, 90 thing, but that's one of the things that we'll be looking at. Okay? There's a special pattern that goes there. So what we're going to do today is we're going to kind of do our checks, and we're also going to do the algebra of it. I don't think we're going to get to the actual plottings and working through that. We'll probably say that tomorrow. So I think we might skip and not worry about starting special right triangles tomorrow. We'll just stretch this for another day, which is fine. We got plenty of time. Let's try another one. I want to find the value of x. Again, it's going to be an isosceles triangle because that x value is the same for both parts. I want to find a value of x that's going to create an obtuse triangle. Okay. So when I think about that in terms of an obtuse triangle, I have to go back and remember, okay, c squared, is it going to be bigger or smaller than the a squared plus b squared? It'll be bigger. So I write it out. The c squared has to be bigger than a squared and b squared. So 144, is it okay if I just write 144 right away for that, for 12 squared? Are we okay with that? It's going to it has to be bigger than a squared plus b, oh, sorry, x's. Again, what is x squared plus x squared? Good. Can you guys, when I do inequalities, I usually do something like this. Is that a true or a false statement? 3 is less than 5. You okay with that? If I say that backwards, what do you see? Okay. So 144 is greater than 2x squared. If I say that backwards, isn't it 2x squared is smaller than 144? You okay with that? Now, it's just me. I like, when I do inequalities, I always like to have my variable on the left. I don't know why, it's just how it's always been in my brain to do it that way. So just to show you guys, I flip it a lot of times by just reading it backwards. There's something that's ingrained somewhere in there that the variable x is always on the left. Don't know why, it just is. Yeah, no judgment. No judgment zone, okay? Divide by 2. We're going to get 72. And now you take the square root of that, and what do you get?
You get
6 root 2. Okay. So that means that in order to make an obtuse triangle, my value of x just has to be smaller than 6 root 2.
I did actually.
What's that?
8.4.
Sure. So if I use 8, 6, 5, 2, 1. Yeah. You find the values of x that make it true. All right, let's make this a little bit more difficult. Switching it up a little bit. No longer looking at an isosceles triangle. I'm going to be looking at a scalene triangle, because now, once I find that value of x, one side will be x, the next side would be 3 more than that, and then the third side would be 15. Now, instructions on a lot of these things will be said that the longest side will be the given integer. The given integer here is 15. So you can go ahead and automatically know that that is playing the role of c. Okay? Now, we're looking at it to be obtuse again, so we do the exact same thing we just did. But you have to remember something about algebra. We're going to say 15 squared is greater than x squared plus the quantity x plus 3 squared. and this is where you guys always screw up. Whenever you have junk squared, let me rephrase this. What's 3 squared? What does that mean? 3 times 3. What does junk squared mean then?
Junk squared
It means junk
times junk.
times junk. Now, if it says x plus 3 quantity squared, it means x plus 3 times.
X plus 3.
It does not mean x squared plus 9. It means you have to write it out twice. You have to remember how to FOIL.
When that's simple.
You have to
Oh,
multiply
my goodness.
binomials together. Okay?
That'd be
Remember foiling Billy binomial?
Oh, Billy binomial.
See, thank you for remembering Billy binomial. Nobody remembers Billy.
The eyes?
Yes.
The nose?
You guys know Billy?
Nope. No.
Let's make an acquaintance.
I kind of don't want to.
Here's Billy.
2x.
First, outside, inside, last.
I hate that's too much. That's too many.
Like if you're kind of forced.
It's Billy.
It sounds like
Okay, what's that on the
He has some really weird eyes.
Okay, look at his brain.
Oh.
Eyebrows. Like Charlie Brown is what
He looks weird, but he still looks right.
His head looks like a butt.
Anyway, so when you multiply that out, you're going to get x squared plus 3x plus 3x plus 9. Huh? First, outside, inside, last. There's this thing called algebra. You had it last year.
What?
I know, it's crazy. Couple of reoccurring themes that happen all throughout my high school math classes. Writing equations of lines, slope-intercept form, things like that, as well as foiling
I love
and
foil.
factoring.
So
Another thing that
can you
happens all the
simplify
time.
that?
What's up?
You can simplify that, right?
Yes, sir. I just haven't gotten that far yet.
X squared plus 6.
So here we get 15 squared is 225.
Something like that, yeah.
We have x squared plus 6x plus 9. So now we need to do a little bit more work.
Don't you have to add the other x squared?
Oh, thank you. I forgot to write that down. I did all this first.
Well, so you.
So combine like terms, and when we need to solve for x here, what we're doing is we're solving a quadratic equation. In order to solve a quadratic equation, you're setting aside equal to 0. Now, don't worry about this less than or equal to, or less than symbol or greater than symbol or anything like that right now. You set it up the exact same way as you would if it was an equal sign. So here's what we're going to do. I'm going to move the 225 over by subtracting 225 here. I'm going to combine my like terms. I'm going to say that 0 is bigger than 2x squared plus 6x minus, what is it, 216?
Yeah, something like that.
Now at this point, there's a couple of different things that you can go ahead and do. What's wrong, Brett? I wouldn't quit because, like I said, you're going to see factoring and foiling problems a lot of times throughout the course of second semester. It happens in just about every single chapter, and you're going to see it over and over again. Now, you can do one of two things. If you remember factoring rules, the first rule of factoring was always to look for what? Greatest common factor, the GCF, right. So the first rule of factoring, no matter what I wind up with, is there anything that that all three of these terms have in common? Two. So I factor out a 2. If I factor out a 2, I'm left with 0 greater than x squared plus 3x minus 108. Now, you guys have all learned many, 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 many different ways of factoring. What times what's a negative 108? You add together to get 3. That's one of the methods that I grew up using. It's pretty much the method that I still use. But when you get into things like this, since the numbers are kind of large for that 108, you might not know all your factors. You could always fall back on the quadratic formula. Yep. Happy holiday. So, yeah, it's the song. X equals negative b. plus or minus square root b squared minus 4ac all over 2. Now, I'm not gonna lie, guys. Not gonna lie. This shows up time and time and time again. Okay? You're gonna need to remember that. Okay? Now remember what the A, B's, and C's stand for. They are the coefficients of the quadratic. Okay?
This is the what?
Quadratic formula. Okay?
So we're gonna use this.
A lot. You're going to use this a lot second semester. You were supposed to have used it on one of the problems on the homework from 7.1 that nobody asked about. So that told me that you guys all knew how to do that.
We did, just we forgot.
Oh, there you go.
See? Almost.
So we start using this.
What's a U divided it by 2?
Yeah, the only reason why I divided it by 2 is it just makes the number smaller. You could have.
You don't have to.
You don't have to. You wouldn't have, because it would simplify later on anyway. So if I go through this, I have, what's the opposite of a positive 3? Then I have 3 squared minus 4 times 1 times negative 108 all over 2, because it's 2 times 1. Now, I'm pulling coefficients. You guys all did this last year. I know you all did this last year. You had to do this last year in order to pass algebra. Bless you. Now, what we need to do here then is multiply through what's underneath the radical first. That is called the discriminant. The discriminant is the junk underneath the radical. I never want students to try to type all of it together at once because you're going to screw up. So what I want you to do is type in your calculator the following. 3 squared minus 4 times 1 times negative 108. And notice, I'm typing it in the calculator the exact same way I wrote it down with just parentheses.
I'm gonna get on that test.
What's 2 times 1?
I got 18%.
Oh, his X.
Alright, so there's a 1,
And
so
I'm
1 is the
still-
coefficient, if there's no.
To this day,
So what if
to
we like
this
put a
now.
little 2 on top or no?
We're just
It's
doing
just
the
2,
discriminant
it's 2 what's
right
underneath
now.
there.
Just doing that.
And I get that.
I
Okay.
know, but.
That's what goes underneath the radical. Okay? Take the square root of it. So what happens here is that you have the following problem. What do we have, 21? I get negative 3 plus or minus 21 divided by 2. That means my 2 possible values of x are going to be negative 3 plus 21 divided by 2 or negative 3 minus 21 divided by 2. And I want you to think about this here. One of these answers doesn't make any sense. Be the negative in this case because you have a negative side length.
No.
Can you measure out negative?
No.
No, so you can't have a negative, you can't have negative side length. So, what is negative 3 plus 21?
18.
What's 18 divided by 2? Bless you.
Plus negative.
What's that?
Never mind.
So the only answer here that's going to work is if x is equal to 9. That's how that works. Okay? It's going to take a little time to remember how to do that. I guarantee it.
And I thought second semester was supposed to be easy.
Right. This is hard already. And it's day what? Day 3? Yeah, day 3. Oh, looks like I finished this semester.
All right, we're trying to get this out to you real quick here. What I want you guys to do is the first, do numbers 1 through 6.
Thank you.
Mr. Murphy.
Hold on, just
Is that class easy?
start with those, okay?
This is
1 through 6, and then 15 through 20. Use a separate sheet of paper, guys. Don't lose this, because we're going to use this for tomorrow as well, okay? We didn't finish all of it up. Yeah, that's fine. But you want for like the back side, you're gonna need more space because you're gonna have to foil stuff out and all that.
Do the whole
Right.
thing if you get out your own head.
What's that?
Yep.
Yep.